Hello students, in the previous class we were dealing about irrational numbers, how to prove irrational by contradiction method. In today's class, the next part of the lesson, that is rational number and their decimal expansion. You know, there are two types of decimal expansion for the rational numbers. Either it can be terminating or it can be non-terminating and recurring. You can find whether it is terminating or non-terminating without actually dividing. So, there is a theorem, you can see the statement of that. Let x be a rational number whose decimal expansion terminates. Terminates means it stops. The x can be expressed in the form of p by q. You all know rational numbers can be in the form of p by q, where p and q are co-primes and the prime factorization of q in the sense the denominator, is of the form 2 to the power of n, 5 to the power of m, where these powers n and m are non-negative integers. Non-negative means you can take 0 to infinity, any number. Negative values you should not take. So, general to say, if it is terminating rational number which terminates, it will be in the form of p by q and prime factorization of q will be of this form. For example, I will take 1.5. 1.5 it's terminating because after decimal expansion 5 is there, it stopped, it's not repeating. This 1.5 can be written as 15 by 10. You can see here p by q form. If you want, you can simplify this, is equal to 5 3s and 5 2s. Now if you see the decimal expansion of the denominator q, 2 can be written as 2 to the power of 1, 5 to the power of 0. So it is expressed in this form. Another example, if you want to take, you can take 1.25. This is also terminating, it's not repeating. So 125 by 100 we can write. If you want, you can simplify this again. 25 4s, 25 5s. It becomes 5 by 4. Q 4 can be written as 2 square into 5 to the power of 0. It is in the form of 2 to the power of n, 5 to the power of m. So every terminating decimal expansion, the prime factorization of q will be of this form. Now, if you have a rational number in the form of p by q and q is having the prime factorization in the form of 2 to the power of n and 5 to the power of m, then if you want to write that p by q in the form of decimals means it will terminate. This is the converse of the previous theorem. Example, you have a number 2 divided by 2 to the power of 1 into 5 to the power of 1. It is in the form of p by q and q is in the form of 2 and 5. Can be written as 2 by 10. The final answer will be 0.2. You can see here it's terminating. For example, you have another 7 divided by 40. This 40 can be written as 5, 8, 2 fours, 2 and 2. 2 to the power of 3 into 5. It is in the form of 2 to the power of m and 5 to the power of n. If you calculate this, if you divide this, surely it will terminate. So this is the theorem. If it is in the form of p by q, q is in the form of 2 to the power of n and 5 to the power of m, surely the decimal expansion will terminate. There is a next theorem for this. I will not write the statement, just I'll explain the theorem. For example, you have a rational number in the form of p by q. Q is not in the form of 2 to the power of m, 5 to the power of n. In this case, if it is not in the form 2 to the power of n and 5 to the power of n, then the decimal expansion will not terminate. You will get recurring in this case. So generally, what you should know here, if you want terminating decimal expansion of a rational number in the form of p by q, q should be in the form of 2 to the power of m, 5 to the power of n. For non-terminating, q not in the form of 2 to the power of m, 5 to the power of n. These are the concepts here. What questions you can expect from this? I'll be dealing with that. Check whether the decimal expansion terminates or not. They can give a question. For example, 13 divided by 25. If you want to know whether it is terminating or non-terminating, check the denominator. 25 can be written as 5 square into 2 to the power of 0. Here you can see it is in the form of 5 to the power of m, 2 to the power of n. Therefore, it terminates. And one more question can be added here. After how many decimal points it terminates? Here you can see 13 by 5 square. If you want to know after how many decimal points it terminates, just see this 5 square. The highest power is 2 here. It terminates after 2 decimal points. If you want to write in the form of terminating means, what you do? 13, 5 square, 5 to the power of 2 is there, multiply by 2 square and divide by 2 square. 13 into 2 square becomes 4. 5 into 2 is 10. Both are having square, means we can write 10 square here. 13 into 4. 13 fours, it's 52. 52, 10 square becomes 100. The answer becomes 0.52. It terminates after 2 decimals. 2 decimals. So one more example. Any number we can take. 17 divided by 30. You have to check whether it is terminating or non-terminating. Take 30. 30 can be written as 5 into 2 into 3. 5 2s are 10, 10 3s are 30. 30 is not in form 2 to the power of n, 5 to the power of m. One extra 3 is there here. So generally, if any other number comes, we can write here, it's non-terminating. It has non-terminating decimal expansion. So any other number comes means it's non-terminating. Just you have to know this. One more example we'll take. Three divided by 1000. 1000 can be written as 10 cube, and 10 cube can be written as 5 cube into 2 cube. So q is in the form of 5 to the power of m, 2 to the power of n. Therefore 3 by 1000 terminates. You can see what is the highest power here. 3 is the highest power. It terminates after 3 decimals. So I think students have understood how to verify whether it is terminating or non-terminating. For example, you have a question like this: 71 divided by 5 square into 2. Directly if you see 5 square into 2, you can say it is terminating. After how many decimal points it's terminating means see the highest power. After 2 decimals. If you want this in the form of decimal expansion, 5 square, this 2 also you have to make in the form of 2 square. So multiply by 2 and divide by 2. If you divide by 2, it becomes 2 square. 71 into 2, it's 142. It becomes 5 into 2, 10, 10 square. 142 by 10 square is 100. The answer is 1.42. It terminates after 2 decimals. So this is the way to solve the problems. There is a worksheet attached to this video. Solve this. At the maximum, you can expect a 1 mark question from this, or you can expect a MCQ from this. Any kind of MCQs, terminating or non-terminating, or after how many decimal points it's terminating, or the answer of this, anything can be expected. So keep in your mind, for terminating 5 and 2 is important. If decimal expansion prime factorization is 5 and 2 means it's terminating. Please solve this. This is almost the end of the chapter. In my next video, I'll be dealing with some important examination questions. I hope so. Students will follow. Have a nice day.